We would like to demonstrate for you the components and use of the Hti demo kit. Included in the demo kit is the plastic case which houses all components, a variable tensioner with bridge, load cell, and threaded polar bar, a load base with stud and nut, a hydraulic nut, a hose with quick connects, and a hydraulic hand pump. To use the variable type tensioner, first you would place the bridge with nut rotating socket onto the load base. Then the load cell would be placed on top of the bridge. And last, the threaded polar bar would be screwed down onto the stud. Note the yellow line as it disappears into the load cell. If this line appears while tensioning, stop tensioning immediately because the tensioner is about to overstroke and release pressure and reset. Once the polar bar is threaded all the way down, it is backed off 1/4 turn. The hydraulic hose is connected to both the tensioner and to the hydraulic pump. When using the hydraulic pump, first you close the needle valve so that pressure can be built up. For this demonstration we will be pumping to 1000 psi. The tensioners are rated to 21,750 psi. Our load base is max pressure of 5,000 psi, but for this demonstration we will be going to 1000 psi. Once the pressure is achieved, we return to the tensioner, and using a Tommy bar you can rotate the nut in a clockwise direction to secure it down against the load base. Once the nut is tight, you can open the needle valve on the pump, releasing the hydraulic pressure. And returning to the tensioner, the next step is to recompress the tensioner. Since the tool has stroked out a little bit, the polar bar needs to be screwed down, which forces the oil back to the pump and resets the piston to the correct height. Once the polar bar has been tightened, you can loosen it back up and remove it from the load cell. Unhook hydraulic hose, remove threaded polar bar, load cell, and bridge with nut rotating socket, and you can now demonstrate that the nut is tight. Now to demonstrate detensioning of a stud, the bridge, load cell, and threaded polar bar are reattached to the load base, threading the polar bar down all the way, but now for detensioning we run the polar bar backwards 2 complete turns. The hose is hooked up to both the tensioner and the pump, and the needle valve is closed on the pump so that we can raise pressure. Now in detensioning we are going to raise the pressure slightly over the pressure which we tensioned at. In this case we will go to roughly 2000 psi. Returning to the tensioner and using the Tommy bar, the nut can be turned in a counterclockwise direction until it is disengaged from the load base. Once you are through with this, return to the pump, open the needle valve on the pump to release the hydraulic pressure. Once pressure is released, return to the load cell Again, there is still a slight amount of stroke on the load cell, so insert the Tommy bar and tighten it to recompress and return the oil to the tank. Once this is done, you can remove the threaded polar bar from the stud. After disconnecting the hose and removing all components from the test base, you will note that the nut is now detensioned from the test base. Now to demonstrate using a hydraulic nut, the first thing we need to do is remove the hex nut from the load base and screw down the hydraulic nut onto the load base. A hydraulic nut, of course, in actual use replaces a hex nut and remains with the job. The hydraulic nut is screwed down all the way till it contacts the load base. Once screwed all the way down, we can connect the hydraulic hose to the nut and to the pump as before. Once connected to the pump, the needle valve is closed on the pump as before so that we can build pressure, and the pump is operated to bring the pump to 2000 psi. Again, the nuts are rated typically to 30,000 psi, but for this demonstration we are going to 2000 psi because of the limits of the load base. Once the hydraulic pressure has been applied, you can rotate the locking collar in a clockwise fashion, which transfers the load from a hydraulic load to a mechanical load, and the hydraulic oil can be released. The load in the hydraulic nut is then taken with the locking collar up against the housing. When you look at the load base, you will notice that the rubber O-ring is compressed and that the load is securely in place with the hydraulic nut. To demonstrate detensioning a hydraulic nut, the hydraulic hose is hooked up to the nut, which is under tension. The needle valve is closed on the pump so that we can build pressure. The pump is operated to bring the pressure slightly over what we tensioned at, in this case around 2500 psi. When returning to the nut, now the locking collar is loose, so it can be rotated counterclockwise. Once fully rotated back, you can release the hydraulic pressure, which will allow the nut to restroke to its original position. Unhook hydraulic hose, and you can now freely spin the nut off of the test base. This concludes the video of demonstrating the hydraulic accessories from Hydraulics Technology.